All right, let's take a look at the unit circle. The unit circle has a radius of 1 and is based around our special right triangles. I'm going to show you kind of where the unit circle comes from, and then I'm also going to show you a hint and a few tricks to help you fill out the unit circle. So our special right triangles, or at least the things we're dealing with, are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And this also includes their radian counterparts. All right, so this would be 0, this would be pi over 6, pi over 4, pi over 3, and pi over 2. So these are the radian counterparts of those degrees. Now, our trig functions are sine, cosine, and tangent. So in just a minute, I'm going to show you kind of a trick how to fill out this table that helps us do our whole unit circle, and also you're going to kind of get the gist of where it comes from. So now we're going to take a look at how the unit circle is kind of generated using those special right triangles, or at least where the things come from. All right, so the unit circle has a radius of 1. So that means that some point on the circle, if I draw a line from the center of the circle, so this is just in quadrant 1. If I draw a line from the center of the circle, this is a measurement of 1. It's 1 unit, okay? Now, what we're saying is that I can create a 90-degree angle using my x-axis and my y value with that radius of 1. This x-axis, we can think of that as cosine, the y-axis as sine, and then my tangent is the line tangent from that intersection down to the x-axis. Okay, so we're creating a triangle. All right, the cosine of this angle, which we'll call theta, the cosine of theta is the x value of the coordinate, and the sine of theta is the y value for the coordinate. Now, the reason this comes in handy is because we're specifically using special right triangles, meaning we're using 30 degrees, 45 degrees, and 60 degrees. Since the unit circle is based off of these, if they ask you a question, and by they I mean math teachers and math people, if they want to know the sine, cosine of tangent of some angle, and they don't want it in degrees, if they don't want it in decimals, it's going to be one of these special right triangles. Now, these special right triangles also extend past 30, 45, and 60. They go around the whole circle, but it's all relative to this, and that's what the unit circle is about. So if I look at this and I think about the fact that cosine is my x, sine is my y, cosine is x, sine is my y, cosine is x, sine is y, what I'm going to get from using my hypotenuse, or the radius of 1, is what generates the unit circle. All right, so if I look at this, this is 1. All right, we know that on 30, 60, 90, which we talked about in special right triangles, that the short leg of my triangle is half of the hypotenuse. So this part right here should be 1/2. We also know that the long leg is √3 times the short leg. So this would be square root of 3 over 2. So notice that the cosine of 30 would be √3 over 2. The sine of 30 would be 1/2. Now, if I come down here and look at a 60-30 or 30-60-90, just turn a different way, this would be relative to a 60 degree inside the circle, but it would have these same measurements, meaning that this one would still be 1/2 and this one would still be √3 over 2. Okay? Now, when I come over here to the 45, 45, 90, if you remember, the hypotenuse for 45 to 45, 90 is √2 times my 2 legs. So in this case, I would have to divide by √2 going back. And when I do that, I end up getting √2 over 2. All right, so these values are the values that are used for the coordinates of the unit circle. All right, and we're going to take a look at that in just a minute. Now, I'm going to show you the trick, or at least the only trick I know in terms of finding these values. So I can use this trick to fill in the table, which will give me my sine, cosine, and tangent for all the degrees that go from 0 to 90. And then all the rest of the unit circle is based on these. All right, it's just like they literally just change signs and switch places, okay? So the way I start off is I always start with sine, and I go 0, 1, 2, 3, 1. Now for cosine, I'm gonna do the same thing but backwards, but I'm gonna go ahead and finish sine first. So all these middle terms get put over 2, and the 2 and the 3 get square roots. So the sine of 0 is 0, the sine of 30 degrees is 1/2, the sine of 45 is root 2 over 2, the sine of 60 is root 3 over 2, the sine of 90 is 1. That's the same values we got just a minute ago when we did my special right triangles. Cosine is the exact same thing as sine, but backwards. So 1 goes here, root 3 over 2 goes there, root 2 over 2 is in the same spot. This is 1/2, and this is 0. Now, tangent is sine divided by cosine. So I'm literally just gonna take this divided by this, okay? So let's go ahead and address the ones that are quick and easy to do. 0 divided by 1 is 0. Root 2 over 2 divided by root 2 over 2 is 1, because anything divided by itself is 1. 1 divided by 0, we can't do that, so that's undefined. All right, now the 2 in the middle, pay close attention. You don't want to mess these up. When I divide root 3 over 2 by 1/2, it's really like saying root 3 divided by 1. Well, root 3 divided by 1 is just square root of 3. When I come down to this one, it's 1 divided by root 3, which I can't leave the radical on the bottom, so I have to multiply the top and bottom by root 3. But it gives me root 3 over 3. So when I learned how to do this and I learned this pattern, I just learned how to go 0, 1, 2, 3, 1, put them all over 2, root these, write it backwards, 0, 1, undefined, root 3 over 3. Okay, I just try to remember the things that were difficult and created the rest of the things that were not so difficult to remember. Did you hear the joke about the hipsters? Yeah, I'm pretty sure I'm the first one that ever heard it. All right, so I zoomed in quite a bit on this blank unit circle. You can print these off. If you Google unit circle, a lot of times it'll come up already filled in. But I'm gonna show you where everything comes from. Everything that I'm getting ready to do is based on those special right triangles, and then based on how they translate to the rest of the unit circle. I'm gonna write as neat as I can and as small as I can, so hopefully you can see. But just follow along and we'll see how it goes. All right, so the first thing I'm gonna do is I'm gonna fill in the degree measurements of the whole circle. All right, so the unit circle or a circle just in general, if we're doing measurements, they go in counterclockwise order. So we start with 0, 30, 45, 60, 90. So there's my first quadrant. All right, so my first quadrant helps kind of sort of generate the rest. I keep going from there. So each one of these is going up by 30, and each one in the middle is going up by 45. All right, so if I keep filling it in, so we got 120, 135, 150, 180. So I added 30, 30, 30, 45, 45. All right, so I can keep going. All right, so that'd be 210, 225, 240, and this one is 270 degrees. My degree mark's kind of out of place. All right, so then add 30, so this is 300. This is 315. This is 330, which brings me back to this one. So it's 0, but it can also be 360 degrees. It can be either one. All right. So from there, we have all my measurements in degrees. We also want to have my measurements in radians. So I'm going to show you a hint on kind of how to do the radians part. This is kind of how I learned how to do it. The first thing I'm gonna do is I'm gonna set up the bottom of each fraction. So every radian that I write is gonna be pi over something. And so I learned a trick that made things easier for me. So when I start over here, this is pi over 6, pi over 4, pi over 3, pi over 2. All right, so here's the trick that I learned to help me with the unit circle. So everything else that I'm doing based on this, all right, I'm looking at this. So if this one's pi over 3, this one's pi over 3. If this one's pi over 4, this one's pi over 4. If this one's pi over 6, this one's pi over 6. And from there, I just change the numerator. So there's gonna be a number in front of the pi on top of the fraction, but I can go ahead and set up the pi over part for the whole thing. So everything kind of stays in the same general location. So that's pi over 3, pi over 4, pi over 6, and then this one is just pi. Pi over 6, pi over 4, pi over 3. And this one is pi over 2. Here's another pi over 3, pi over 4, pi over 6. Hey, bud, can you wait over there? Thanks, bud. So once I go from here, all right, now I have to figure out my numerator. So here's the trick, so pay close attention. For this one, so when I'm over here doing this pi over 3, my numerator is 1 less than the bottom. So that gives me 2 pi over 3. Numerator is 1 less than the bottom, 3 pi over 4. Numerator is 1 less than the bottom, 5 pi over 6. All right, now for the rest of them, for the bottom half of the circle, I'm gonna do the same thing. All right, or I'm not the same thing that I just did, but I'm gonna do the same thing for this part and that part, okay? So if I follow the line from this pi over 3 to that pi over 3, if I follow across the line, all right, I'm just gonna add up the numerator plus the denominator. So if this is 1 and that's a 3, 1 plus 3 is 4. All right, for this one, 1 plus 4, so this is 5 pi over 4. For this one, 1 plus 6, 7 pi over 6. Now I'm gonna do the same thing based on these to get these over here. This is 2 pi over 3. 2 plus 3 is 5, so it gives me 5 pi over 3. 3 plus 4 is 7, so this is 7 pi over 4. 5 plus 6 is 11, so that gives me 11 pi over 6. There's all of my radian measurements. All right, that's a trick that I learned when I was learning the unit circle when I was in high school. All right, now, all the coordinates are x and y coordinates for everything. All the coordinates are x and y coordinates for everything, and they all stay very similar, and I'll show you what I'm talking about. So each one of these is an x and y, and if you remember, and I'm gonna write it right here so we can see, sine is my y value, cosine is my x value. So if I look at that chart that I made, it lets me fill in everything, okay? So when I did 0 degrees, my y value is 0, my x value is 1. All right, when I did 30 degrees, my cosine for 30 degrees was root 3 over 2, and this was 1/2. For 45 degrees is root 2 over 2, and root 2 over 2. And for 60 degrees, it'd be 1/2 root 3 over 2. And then for 90 degrees, my sine is 1, my cosine is 0. All right, so every one of those I just got from that table we made just a second ago. All right, now, all the rest of the circle is the same exact things. All right, just the only thing that changes is the sign. So for instance, if this pi over 3 was 1/2 and root 3 over 2, this one is gonna be 1/2 and root 3 over 2. But now it's over here where my x values are negative, so this is negative 1/2 root 3 over 2. So this one's negative root 2 over 2 and root 2 over 2. This one's negative root 3 over 2, positive 1/2. And then this one is negative 1 0. So notice how my coordinates still have the same fractions. The only thing that changed for each one is the sign. All right, now I'm gonna do the same thing down here. So if this 5 pi over 6 is negative root 3 over 2 and 1/2, it's still gonna be root 3 over 2 and 1/2, but now they're both negative because it's in the third quadrant. This is still root 2 over 2, root 2 over 2, but now they're both negative because it's in the third quadrant. This one down here gives me 1/2 and root 3 over 2, but they're both negative because it's in the third quadrant. This one gives me 0, 1, but it's negative because the y value is negative. So notice how it's a lot of the same values repeated over and over, but just the signs are changing. So this one right here, I would have a positive x now, but I'd still have a negative root 3 over 2. I have a positive x, negative y, positive x, negative y. So now I have done the entire unit circle. I showed you the best way that I can and how to create it. If you follow along a couple times and just watch me go through it, hopefully it'll make sense and you can use it. But the main thing is that the higher ups in the math world want you to be able to create the unit circle so that when they ask you what's the sign of 5 pi over 6, you can tell them it's 1/2. Okay, so using a unit circle along with that table we made earlier, you can find the coordinate for any of the special right triangles and how they lay on a circle and what quadrant they lay in without having to use calculator.